Hello, everybody. I hope you are hearing me well. So I'm Sergio Mendes from Lusodata, company located in Portugal, Europe. It's my first time in the United States. I appreciate being here. And I was hoping to show you some use of CA Plex model API. We've done it a few years ago. Okay. I hope there are some Plex developers in here. Okay, for those of you who don't know what CA Plex model API is, I'm gonna tell you afterwards. Let me try. Okay. So we started working in this particular client, and it had an infrastructure of client server based on IBM iSeries servers and Windows PC clients. Okay, and we were using the C++ generator by the time. And I'm gonna focus on this particular stage of DevOps, which is the first one, the development stage and the object collection stage, okay? So we were developing in Portugal, and we were deploying objects to Portugal and a few more countries abroad. These server objects were collected after they are built. They were collected and distributed manually. Okay? We used save files and we used the FTP to have them deployed and installed by the system administrator at the remote locations. Now, the client objects, as you may know, are a little bit trickier to deploy. But that's not the point here. The point is, how do I collect the correct ones, the correct objects that I'm building with my CA Plex? And how do I avoid the mistakes that are that usually happen? This was back in 06 and 07, and fortunately, CA released the Plex model API by that time, and we decided to have it a try. So we use it to put our changed objects, changed functions, either direct changes or indirect changes, into Plex lists, and we used these Plex lists to have an external application, collect them and store them in proper update packages that were deployed later on. So the solution was to use the Plex model API to process those lists, and we developed another Plex application, actually, which we called Logest. You're going to see that reference in the next slides. To use model API and have it collected the right objects into the update packages. So again, this is the whole picture of the DevOps we used to do. In the left side, you have the Plex build folder. For Plex developers, they know what it is. Is the place where the objects are compiled and built, and you have another folder that's gonna have the objects to be deployed later on. So let's focus only on the left side because I only have 20 minutes. So what's the model API? It's a COM-based API, okay, COM framework, and it offers over more than 50 methods to consult the local models and even modify local models. Okay, we can use the information we extract from it to do a little bit of change management. It's documented in Plex as well. Okay. You don't need to go and get information in the internet. It's documented in Plex. And it's now in the version 3.0 with the better exception handling. Here is an image of the Plex model API documentation. Okay, it's under reference model API, and there it is. All the information you need, it's over there. Okay, first I started to make a presentation with the whole steps for doing this and showing all the source codes we used to do this, but I would need about an hour to do the presentation, so I had to cut some slides. But I have the version, the complete version. I have it, and I will have it available for you to download if you are interested in. So this is the first thing to do, is to initialize the COM framework. Okay, this source code starts the COM framework. From here, we can use the Plex model API. Another source code of interest, actually, it's the first one. Remember, we are storing functions inside Plex lists, and then we are going to iterate the list contents to do the rest of the operation. So this source code here is to get a pointer for the list object, providing the list's name. Okay, so we give this source code the list name, and it returns a pointer to that list object, which is going to be fed to next APIs further on. This one here will get the function name, the model function name that we are iterating inside that list, and we use it, of course, to get function name, etc. I'm not going to show any more slides. I have the application to show off. So this is the last one. We use this to free the COM framework. Okay, it frees all the memory. It's the last one. Next, I'm going to show you this working. Let me switch. Okay, I have this test model. This is a local model which has my test list over here. Okay, which has these functions. Okay, I have function number one, which is a WinC with a panel. It's a panel function. I have function two, which is another client function, but with no panel, with no panel file. On purpose, I have a third function that is not implemented. Okay, I have it registered in the list, but it's not implemented, so I can see what Logjet is going to do with it. I have one server function, Windows NTC function, and a couple RPG functions as well. Okay, this prototype is collecting the Windows C++ DLLs, but not doing anything with the RPG functions. Firstly, because I am not connected to an IC server. So what I'm going to do is show the application itself now. There it is. Oh, it isn't here. You open it. Okay. This is the application. This is another Plex application. And I'm gonna create my update package, okay? I have 3 applications here. I'm gonna choose the first one, which is a beauty center application. And I have no update package yet for it. So I'm gonna create a new one, okay? In this panel, at the top, I have one field where we are going to put our list name from the local model, and the application will do all things from here. So what I'm going to do is to generate and compile this list. Okay. I forgot my mouse. I have to use this joystick. All right. There it goes. Visual Studio is compiling them. And they are compiled. Okay. Let me show you the folders. Okay, this is my client build folder. Okay, you can see there is my function number 1 DLL, its PNL file, and function number 2 DLL. Okay, and function number 3 is the one that was not implemented, so it's not here, of course. Now that I have the objects built, I'm going to use logest to process this list. My list's name is test. And now go analyze that. Okay. It processed all the list content and then analyzed the built objects. Okay. As you can see, there is one red line over there. It's the function which was not implemented. Okay. This shows one useful thing. If for some reason we are compiling the big list, big number of objects, some may not be, may get an error. They don't compile. So we caught them, we catch them in here. Okay, but this one was on purpose, just to show it. I'm not gonna connect this object here, so I'm gonna unpick it. Oops, sorry. Okay. I'm gonna give some description to this update package. I'm gonna call it first version of my application. Here I'm gonna choose the system which gonna have them collected in, and I'm gonna give him a folder name. As you can see, I'm going to call it version 1.000. Okay. Logest is alerting me that I have defined this application as a Windows NTC function. Okay, all back office. But I have 2 RPG functions in this list, so it's alerting me that 2 RPG functions were found in an application that is supposed to be all Windows. Okay, it's only a warning, not important. So I'm going to answer yes, confirm. Okay, as you can see, now the objects disappeared from my release folder, but are now stored at my update package folders. Okay, this is another folder, and my objects are now inside this folder here. So okay, in RPG should be those 2 RPG functions. It could be a save file or something like that. It's not implemented. The WinC functions are there, and the server function is here. Okay. There's another useful thing about using Plex Model API, which is the change management thing. Let's imagine, for those of you Plexers, if you forgot to turn the debugging off, okay? You've been generating certain functions in debugging mode. You know that if you do that, the DLLs are bigger. And we are not supposed to send debugged functions into production environments, of course. Okay. Let's simulate that. I'm gonna recompile my list. Okay, let's imagine it's my version 1.001. I should have only built it, no problem. But I'm gonna generate this one here in debugging mode. Okay, gonna turn this on. And let's generate and compile this one in debugging mode. So what I'm gonna do is reuse my list and have logest connect these objects again. Okay, test, my test list. Okay, it's gonna do the same, but the first one, it's alerting me that these functions, DLL, had a certain size in the previous collection, but in this new collection, it overcame the 2% its size. So it might be something wrong with it. In this case, it's the debugging mode is on this function. So the developer knows he might have forgotten to turn that off. Okay, so let's go back and regenerate that function without the debugging. Okay. It's this one. Let's refresh here. Okay, the warning is gone. That everything is normal again. So this is my first second release. And it's V1001, for instance. Okay, it is alerting me again. I'm going to show you, there are my functions on the left side. On the right side, we are in our first release. Okay, and I'm going to grab those objects into. Okay, my second release is done. Okay, they are now inside this one. There they are. From this point on, we use this application to do the developments to remote sites. Okay, that's beyond our focus here. So, oops. Okay, that's it. I'm finished. I hope. Huh? Oh, sorry. This. I hope you have enjoyed it. It's my first presentation ever. As you might have seen, I hope you enjoyed it. Thank you very much.
So, well, I was saying, from Uzat, been working there for a long time, and there's a thing that annoys me when I use some script files. I'll show you, and you recognize immediately what's the problem. So, I have a list of people here. So, what I want to do is to they grouped on behind this. When I expand them, the group works fine on the first page, but you switch to the second page and you do the same. For just the first page, the second page is just a small display file, but it's there. If there was 22 pages, it's annoying. I find it annoying. So I have here a solution for that small annoyance. So I'm setting a scenario for just for our example. It's a company that has a health plan for employees and their households. So we are building a display file function that we allow to show insurers with or without the depending beneficiaries. So the first thing we have to do, and it's done just once, is setting up the environment. The first thing we need is a field. Well, I called it number of lines to load. And it has to be with 4 bytes length, zone decimal, and has that name RR0, because it will match the name of an internal variable on tree. Then we have to append that field to the program data structure on site on tree. That will look something like this. You see, the last line, my unsuspecting line I appended there. Then I built a user source, RPG4. RPG4 actually works on RPG2. RPG works too. COBOL, I'm not sure. If someone tries, and please let me know if it works. The user source is really simple. It's move value to that variable, just that. Well, the setting up is complete. Nothing else is needed. Now we are going to build display file. In order to know which groups I will expand or not expand, I'm using an array, a matrix like any other. If you like to, if you use let's show you 5, something like that, but I'm using an array as one field and one key only. 4 functions for the array: create object, delete object. Everybody knows how it works. But a clear expanded group, which is delete object without keys, clears all the array one time. And the check expanded group. The check expanded group will give me a value of yes on the parameter if it finds that particular key on my array, telling me that that group is to be expanded, or no, that we should be collapsed. See here is a retrieve object. Nothing new about this also. This play file is really simple. It's just, well, sample. Just two columns, very simple. The two options, collapse and expand. Will I use little conditioning on the fields to set the difference between the kinds of records. We'll see it afterwards. Inside the display file, this is the user point to use. It's really, really simple. And this, the first one is, well, of course, clear the records, good practice. Then on initialize control, I'm using a control variable to see if it's time or not to reset the number of lines to rows. We'll be doing it on this on the follow on the next user point. So I'm checking if I did not reset the number of pages. I will do it now and not anymore. This has to be on this user point on the initialized on the device. Then, well, this the control if the group is to be expanded or not. Check it. If it's not to be expanded, then that record should not be shown on this profile. And then finally, the options per field will have to, on expand, call that user source that makes the GADD and enroll that key to the array we created. When you collapse, you do the opposite. You still have to call the user source and remove the key from the array. So what happens instead of what I show you is this. Same thing here. Well, there's no page changing, of course, but on the second page, we made the expand the change, the page didn't change. It's reloading the file. It's not changing the position of the file. This was used on these kind of things, which we imagine other users for this. For instance, if you create a new record, you don't want to list the page where you are. So it will be a technique. Well, that was what I have to show you today. I guess is something I never saw before. And if I have any questions. Any question there? I didn't see it. What's the question? Was
someone says
on the right side.
wow, it's not about
It's not about your use.
Okay. Well, that's our also context. We are setting up an office in the United States. There's a number if you want to contact us. That's my number in Portugal. And my email address if you need to know further things. Okay. Thank you.
Hi everyone. In this presentation, we are going to see how we at Futura Sistemi have developed 3 web client controls to manage maps in Jimbe, our WebGIS for green spaces, surveying and management. Who we are? We are Christian and Mirko. Christian is the sales manager of Jimbe, and I am currently the software analyst at Futura Sistemi that since 1991 develops B2B software. Together, we are going to overview the 3 main web client controls developed in Jimbe, our WebGIS solution that supports municipalities or third-party companies to efficiently survey and manage public spaces such as parks, trees, playgrounds, and so on. We heavily used Plex to generate Java code and CM WebClient for developing user interfaces. Now let's see the WebClient controls. The first WebClient control is to manage maps using open layers to integrate general maps such as Bing, Google Maps, and OpenStreetMap, and active maps, which represent the surveyed objects. Open Layers is a powerful open source JavaScript library for building web mapping applications. It provides a flexible set of tools for displaying maps and geospatial data in web browsers, and supports a wide range of map providers and data formats. This map web client control has been integrated with Street View web client control that implements Google Street View API, which shows the pedestrian's point of view. Here you can see a sample of the achieved result. The map control has several purposes for showing GPS georeference maps, visualizing multiple layers and regulating their intensity, for measuring distances and areas, for searching data, for managing maps zoom, for printing maps in different pie sizes, for drawing active objects such as points that locate trees or playgrounds, multi-lines for roads or bike routes, and multi-polygons for parks or other specific areas, and for defining geo bookmarks, just to name a few. Later we'll see them in the demo. The second WebClient control is the searching path control. We found that Google Directions API suits our purposes. Through the Directions API, we get the fastest street route to get to a destination. Here you can see a view of the searching path control panel, where we can search routes for different kinds of vehicles and for single or multi-destinations. This is a screenshot of the Google Directions web client control. And here we can see how the control is used in a Plex panel. The third web client control implements the visualization of the vehicles on the map, integrated with the map control we saw earlier, which gets the maps and adds a specific layer that shows the real position of the vehicles. We integrated the WebFleet REST API and hardware, like the devices shown on this slide, to enable customers to see where the company's fleet vehicles are. We developed this control because we found that one of our customers' needs was the possibility to know the vehicle's position and, if needed, calculate the shortest possible route to reach the next destination. This is a sample of the vehicle web client control with two vehicles located on the map. Clicking on the vehicle, you can see the main information and the last position registered on the WebFleet platform. We have also the possibility to access to a large amount of data collected from the WebFleet devices installed on the vehicles. Here you can see a few data showed, such as fuel consumption, vehicle self-monitoring, among other things. Now Christian will show you the demo of our web client controls used in Jinve, where you can see how these complex controls are made user-friendly. Christian, the floor is yours. I leave you the screen.
Ragazzi, non si sente nulla? Non vi sentiamo?
Mi sentite? Can you hear me?
Adesso sì.
Okay, okay.
Thank you, Gon.
Thank you.
Cristian,
Okay.
non si è sentito nulla dall'inizio.
Let's have a look at the three main web client controls implemented in Jinve. As Mirko told you, the three controls implemented are a map control, a search control, and a vehicle control. The Java code has been generated by Plex, and the user interfaces have been developed using Siam first web client. The web client map control allows to show and manage maps such as Google Map, Bing, and OpenStreetMap. We've implemented this panel where you can see the layers we have implemented using the open libraries called open layers. And by clicking on each layer, we can enable the visualization of the layer or turn it on or off by clicking on these control buttons. We can also, by using the map control, enable a transparency over the layers in order to show the below layers and make it visible. Our web client map control has been integrated with our web client street view control that allow to show and view the pedestrians from a pedestrian point of view, the map by calling Google Street View using implemented APIs. I'm going to show you how these APIs have been implemented and how is the result. By clicking on a position on the map and clicking on Google Street View, our APIs call the Google services, and we can see the Google Street View where we have access to the movement. We can active or deactive the visualization of the satellite or view the standard map. And there are also the zoom function available in this control. I'm going also to show you how we achieve the result with a map control. The map control is a control that shows the GPS georeferenced maps, as you can see here. So we can use the zoom function as I am showing you. And also in this map control are available some advanced functionalities, such as the measuring distance and areas functionalities. This is the distance functionality implemented, and this is the area functionality implemented by our control, our map control. This map control allows also to printing maps in different formats. By clicking on a specific button, we can give a title to our PDF printing that is going to be generated and choose the format, the resolution, and the page orientation. By clicking on OK, a PDF will be generated with the actual view. We can also perform using our map control data search. We can using it directly on the map by clicking on the right button of our mouse and going to research, such as trees. And we have access to our database with all the trees that have been sensed. We can also reach every single tree by double clicking on it, and we directly reach the selected tree. All these functions have been implemented using the map control. There is also a geo-bookmarks functionality where we can save the current position by giving it a name. And we can go on this bookmark for a later time, so we can move over the maps and work on other areas. And then by clicking on the job bookmark, we can reposition and turn and return to the previous location. This is the map control. This is some of the functionalities that we have implemented using the map control. The third and the last control we've implemented is the search control. That is a searching path control. We've integrated a Google direction APIs for fastest street route calculation for a given destination. It can be accessed by clicking on the map and selecting routes. In this case, there is a list of the destination that we can reach, and by clicking on a destination, our APIs is going to use the Google APIs, and they give this result with the map from Google and the details of the description with the description to reach the destination. We can also switch from satellite or standard map. We can use the pedestrian point of view, so such as like Google Street View and the Google Maps. And we can also use and track multiple routes for vehicles or for other kinds of other types of vehicles, or in third person. We have also the possibility to access a large amount of data collected with an integration we made using an application called WebClient. WebClient is an application that allows to track the vehicle position on the map. We have two examples here. So with the devices that Mirko was talking about during his presentation, using these devices on a vehicle, we can track and gather all the data from these vehicles. With these APIs we implemented, that is the vehicle control, these vehicles are visualized on the map. It's integrated with the map control we saw earlier, and this gives the possibility to show the vehicles on the maps and show the real-time position of these vehicles. If we go over a vehicle, we can get fast information about the vehicle and its current position. Further data are also available accessing on the WebClient site. Here is an example of this data. These are the vehicles represented on WebClient. There is one vehicle here and one vehicle here, and our APIs is able to access the position of the vehicles from WebClient and represent them on the map, as I was showing you here. This is the vehicle position, and this is the WebClient position of the vehicle. By using the WebClient application, we have also access to a larger amount of data, such as the fuel consumption, the maintenance status of the vehicles, the routes and the routes they performed or they did during the day or during the previous day, and many other functionalities. These, as Mirko was talking about during his presentation, these data are gathered by using these devices that need to be connected to each vehicle, and they transmit the data in real time, and these real-time data are then represented on Google on the GIMV maps on our application. This is a view of the third controls we implemented, so the map control, the search control, and the vehicle control. If you need further information or have any questions, please let us know. And this concludes my presentation.